just the fun slide is more entertaining than staring at the text until we start. All right, so today we're going to learn about exponential growth and decay. This has to do with exponential functions. This is 16.2 out of your consumable textbook if you have it. And your essential question is, how can you use exponential functions to model the increase or decrease of a quantity over time? So when we talk about growth and decay, growth is where something is increasing, and then decay is where something is decreasing. Okay, so those terms go together. And your learning goal is still, I can graph an exponential function. So this first slide is for review. This is what we've learned so far about exponential functions. This is everything we've been doing from last week, okay? And this right here, see where it says Desmond's graphing calculator? I'm hoping this is gonna work. This is a hyperlink to open the Desmond's graphing calculator. So like as a student, if I click on this, does it work? No, of course it doesn't work. All right, I'll just open it for everyone. It works on my screen, but then that doesn't really help you. So I'm going to copy this, and I'm going to force open a graphing calculator tab for everybody. And I want you guys to get familiar with using this. I was having you use it last week, and you should be comfortable using the graphing calculator, the Desmond's graphing calculator, to graph these exponential functions, because that is what you're going to need to do on the test, okay? And just use that to answer these questions. So this review slide right here, this is the one that you're going to do right now. All right, I'm going to move my graphing calculator over here. Actually, okay, so I kind of have my slides, my screen split here. So here's our function, f of x equals 4 times 2 to the x power. So that's what you need to type in over here. Everyone needs to do that. F of x equals 4, open parenthesis, 2, close parenthesis. And then to get to the exponent location, you have a couple ways to do that. One is to click on show keypad and then click the A to the B button. Another is to, on your keyboard, type Shift 6. And then that'll give you that little like upwards arrow, which will make you go up to where you can type the exponent of x. Right? So this is what you should get. I need you to do this right now. Okay? Everyone should be doing this. So you kind of have like 3 things you're going in between right now. So you have our Google Meet, you have your Pear Deck, you have your graphing calculator tab that's open. So all these different things happening. And if you type this in correctly, your graph will look like this. If you accidentally put your x just next to the 4, you would get a diagonal straight line. We don't want that. We want an exponential function. And so we're using this to kind of like check our work as we go through this. So we're going to fill in this table for f of x. If x is -2, 4 times 2 to the -2 power. Well, if I go to where -2 is and I look right here, you can actually click and add points to your graph. When x is -2, y is 1. So that's what I'm showing you right now on the Google Meet screen. So if you go back to your Google Meet screen, you can see this. Another thing you can do, see, if you click on the settings wheel and then you click on this table button, it's going to convert it to a table. And it just did all the work for you. This table that it came up with is the exact same table you have here. So all you have to do is copy these values into this table over here. Last week we were doing this by hand. All right, we were plugging in the value of x, evaluating the function to that power, and then getting our output and putting it in the row. Those are all ordered pairs that we're going to be plotting. So you can just use your text tool to type some different values here. We have when x is -2, y is 1. When x is -1, y is 2. When x is 0, y is 4. When x is 1, y is 8. When x is 2, y is 16. When I say y is instead of saying f of x is, it's the same thing, okay? These are ordered pairs that we're graphing over here on this graph. And then for these values, a equals b equals the y-intercept. So we also covered how to figure these values out last week. And so a, if you look at your original function, right here, a, that's the a value. So a is, in this case, 4. A is 4. And b, is a different color. B right here is the value inside the parentheses. So B is 2. The y-intercept is an ordered pair. And it tells us where it crosses the y-axis. And you can see either from the picture, that's at 0, 4. You can look at the table when x is 0, y is 4, or you just I'm using a lot of different colors here, but use whatever colors you want. You don't have to use the same colors as me. Okay, so just where are we getting the y-intercept from? It comes from right here. Okay, when x is 0, that tells us where it crosses the graph. Okay, so that is this ordered pair right here. That point, I could plot all these points too. So -2, 1, -2, 1. Pay attention to the scale when you graph your points. -1, 2, 1, 8, 2, 16. And you would connect those with the line really as best as you can. And this goes on forever in that direction. This goes on forever in this direction. There's no arrows over here on the Desmos graph because you can keep moving it. So they don't put the arrows there, but you should put the arrows in your graph. And then we can learn how to predict the end behavior. This is something else we did last week. So end behavior of x as it moves towards -infinity first, we're showing us here. So as we move towards -infinity, which -infinity is this direction. As I go this way, basically what is happening to the graph as we move towards -infinity. You can see the graph is getting closer and closer and closer to 0, 0, so 0. As x approaches negative infinity, it gets closer to 0. As x approaches positive infinity, so as we go this way towards positive infinity, and sometimes they put the plus here, sometimes they don't. If you don't see the plus sign, it's implied that it's positive infinity. So as we move this way, the x values are increasing, our graph is also increasing and it's going towards positive infinity. Right? So use Desmos to check your work. This is what we did all of last week. If any of this is confusing, you need to go back to the week at a glance from last week. You need to look at those paradox. You need to look at the videos of our lessons, right? Because this is going to be on your test later this week, Thursday. Our test is Thursday. Okay, so moving on to the content for today. We have some vocabulary here. Exponential growth model. So make sure you come back to the Google Meet tab. You can follow along. Exponential growth model and exponential decay model. So the word that is different here is growth and decay. And then when it's a growth model, this is a function that increases with time. An exponential decay model is a function that decreases with time. Okay, so think about the word to grow. Like if you grow and you get taller, your height is increasing. Think about decay. If something is decaying, like it's rotting, it's disappearing. Okay, like if you left out a piece of fruit and it was decaying, eventually it would just go away and decay over time. So you can think of, matching these words up with their other meanings that you might think about. You think about a plant that grows is increasing, a plant that decays is decreasing. It's good analogy there, a plant. And then you have these different values. So this is the basic function. Again, it's really close to this basic function, which I did not write here, f of x, a times b to the power of x, okay? But the only difference here is that instead of f of x, we have y, which I've already told you guys a bunch of times the same thing. Instead of b, we have either 1 plus r or 1 minus r. And instead of x, we're now using the variable t because we're talking about over time. Over time, our x-axis is now, we're talking about time along the x-axis. So it's basically an exponential function, a little bit different representation of the variables and how you represent f of x, they put a y instead. Okay, but these values here, as long as we know these pieces, we can plug it in and graph it. So A represents the initial amount for an exponential growth model and for an exponential decay model. A represents the initial amount. B is different. So B is the same as 1 plus R or 1 minus R, where this is either your growth factor or your decay factor. R is the growth rate. Okay, so the actual R inside the parentheses, that's the rate of growth or the decay rate, the rate of decay. And then T for both of these is the time interval. So we're going to use this to solve some real life problems. Okay. All right, so here's the slide we're on now. Baseball cards. I don't know if any of you guys collect baseball cards. Kind of seems like more of like a older generation type thing. But there's still, if you do have them and you collect them, they're worth tons of money. Back in the day, you could buy a baseball trading card that is sold for $2 and its value increases by 8% each year after it is sold. Find the value of the baseball trading card in 10 years. So this is actually an exponential function because its value is increasing based off the previous amount. It changes how much it's increasing by each year. So the first year, it's increasing 8% off of the $2. But then the next year, now it's not worth $2 anymore. It's worth $2 plus its 8% increase, $2.16. And then from there, it's increasing 8% of $2.16. So it's growing exponentially. And so what we can do is write an exponential growth function for this situation. the growth formula, y equals a times 1 plus r to the t power. This is exactly what we had right here, okay? And so we're just going to plug in the values. A is the initial amount. So, you know, I'm going to use highlighting tool here or underlining. The highlighter tool doesn't really work that well. I don't feel like it kind of covers things up. So I'm just going to underline stuff, right? So our initial amount is the amount that it's selling for at first. That's our A. Please green. So right here, it is sold for $2. And then they're telling us that it's increasing by 8% each year, okay? And then we want to know, finally, what is the value of the baseball card in 10 years? Okay, so all these numbers that show up in the problem are really important to what A is and what R is, all right, and T. So first we write the exponential growth function. Y is equal to A times 1 plus R to the T power. A is your initial amount, which is $2. So we're going to put a 2 in this first box. Okay, plus R. What is R? R stands for, I'll go back a slide. R stands for the growth rate. The growth rate. I'll leave you in student pace, so that way I'm not jumping you around too much. The growth rate, well, it says 8%. When we want to write 8%, we don't want to write 8 and then percent symbol. We want to write its decimal equivalent. So you do have to remember how to take a percentage and turn it into a decimal equivalent. So we'll put a little note up here that the way we take 8% and change it to a decimal is basically 8 per 100, 8 divided by 100. And if you're not sure what that is, you can use a calculator, or you can think of moving your decimal 2 times to the left, 0.08. Right, so this decimal version is what I want to put here, because this is how I'll be able to do my calculations. I don't want to put 8% with the percent symbol. Okay. And now we're just simplifying to the next step. Again, you guys, last week I was showing you all about PEMDAS order when you simplify, parentheses, exponents, multiplication, division, and then addition and subtraction. Okay, we're still using PEMDAS order. Let me move this over here. Right here, okay? But this time we're going to parentheses first, because in the parentheses I have an operation, I have addition. 1 plus 0 and 8/100. When you add a whole number and a decimal, you add this 1 to what's in the whole number spot, which is 0. Okay, so this is going to become 2. And then right here we have 1 decimal 0.8. Okay, so best you can get those things there. I am going to I'm going to rewrite that too. I do this with you guys. I'm sorry. I get way too picky with my own writing, and I have to redo it. 2. Here we go. Yeah, and you can handwrite it. You can use the typing tool. It's really up to you. So all I've done so far is that's just the exponential growth function. Once you write that function, now I need to actually be able to answer the question. Find the value of the baseball trading card in 10 years. So we use the function, but now I know that T is equal to 10. Okay? T is equal to 10. So because it says 10 years, that means we're going to plug in T equals 10 to find out what Y is. And so we just keep these parts the same and then replace the T with the 10. All right, and then we're going to evaluate this. So I'm going to kind of do 2 screens here. want to see how you guys are doing on this slide. I have 6 of you writing on your slide so far. So if you have not started writing on your slide, you need to get on that, please. And you can use the same colors as me, like this person did, or you can use different colors. Totally up to you, unless that is me. It's probably actually me. I don't know. So good. This is good. See, they're plugging in the right way here. And that's why I'm saying you can use these paradox as your notes, because if you're taking notes with us and doing these all at the same time, this is like a really good way to keep track of all your work, because these paradox are there for you. I want to say they last, they're not there forever. Paradox would tell me how long they're actually there. That's, you can see, I know some of you are copying right now. It says sessions. Okay, so you have 30 days to go back and look at all your work. So yes, this works as good for your notes, but after 30 days, it's going to disappear. So if you wanted something more long-term, then you still would need to like screenshot it and add it to some type of a document. Yeah. So anyhow, we're going to go ahead and fill this in. 2. $1.08. Again, next step here. This is 2. You don't have to use all the colors because I know that gets really frustrating. You can use one color and just type. And now I have 10. Okay, now to evaluate this, again, think about PEMDAS order. Don't forget about that. In the parentheses, there's nothing to do, so we move on to exponents. We have to raise this number to the 10th power, and then we multiply our answer by 2. So this is a great time to use your calculator. And you have, let me show you on the Google calculator, because that's probably the one you'd be more likely to actually use. So if you go to a Google search or you open up the Google app calculator, this is what it typically looks like when you search for it. All right, now I want to raise 1 8/100 to the 10th power first. So that would be this button here. You see this X to the Y button? That means I have a different base and a different exponent. Okay. So I think, let me play around with this real quick. If I type in the base and then hit this button, now it's done it to where it wants to know what the exponent is, and then you type in the exponent. Equals. You get this number, multiply that by 2, and then we get our answer. It says to round because we have this little wavy equal sign. That's the approximately 2 equal sign. That's what the wavy equal sign is. So if we round this and we're talking about money, we want to round it to the nearest hundredth. Okay, so how do we round a number like this to the nearest hundredth? Copy. I'll show you. If it'll let me paste. It did. Yay. Okay. Round to, I could say, nearest cent, or to the hundredths place. Which basically means right here is where I'm going to want to round You look next door. I have a 7 right next door. My arrow's a little bit off. So this means I need to go up a cent. So it's actually $4.32 approximately. So if you round in an equation, you start using the wavy equal sign. Okay, or if you're writing out your description, use the word approximately. And then that way people know that you rounded. It's not an exact answer, it's an approximation. So I'm going to give you a chance to get caught up on that. Before we move on to the last slide here, the 11 of you working in here, you want to get this updated, and then we're going to move on to the last slide together. Forgot a letter right here. Hundredths. Let's see, it's the problem. That's my problem. I'm not the best speller. I use Alexa for that all the time. I ask her to spell words for me. I don't have a spell check in front of me. Okay. All right, so I think you are on student pace, if I'm correct. Yeah, you are. So I'm going to go ahead and move forward to this next slide here, because time-wise, we're getting close to the end of our time. We're going to do this last slide together before you guys move on to your asynchronous assignment, which is on HMH today. And so let's see, we have 10 more minutes to do this slide. All right, I'm good on time. 10 minutes. We do 10 minutes. Yeah, like after we do this, you have an HMH assignment, which is only 5 questions. And it's exactly like what we're doing right now, like fill in the little pieces and answer it. One of my computers is totally wigging out. It's like, I don't know what it's doing. Anyhow, here we go. The value of the car is depreciating at a rate of 5% per year. So now if we are looking at a rate that is going down, right? If I go back, this is an example of an exponential decay model because something is decreasing with time. So we're doing the other type. In 2010, the car was worth $32,000. Find the value of the car in 2013. All right, so over 3 years, you know, how much is it going to be worth after that? Again, you know, it's exponential because you're finding the percentage of an amount. Each year is changing the amount that you're finding, the percentage of it changes that way. That's what makes it exponential. And so here is that y equals a times 1 minus r to the t power. That is from right here. That is the way that formula looks. So if we know the initial amount, we know the decay rate and the time interval, we could figure this out. So I'm going to go ahead and move forward on this slide. Again, this is being recorded, so you can always go back to this if you need to. So funny that my computer is going crazy. It's like loading and loading and turning off and on, and I don't know, it's kind of bothering me. Anyhow, we'll do this. I'm gonna like hard power it off because it's really annoying. That's not even working. Oh my gosh, I think I might have to unplug it from the wall. Huh. Okay. All right, so just like on the last question, we're going to go through and underline some important things here. Our initial rate, and try to stay consistent, is green. So why did I just say initial rate? That's not the initial amount, not rate. The initial amount. The initial amount is $32,000. So I'm going to underline that. That's going to go right here. That is this first box of A, 32,000. All right. The next thing you need to know is the rate, R. R is the decay rate. The decay rate, I used blue. I use blue again. Is depreciating. That means to decay. 5% per year. So 5%, again, you want to convert 5% to a decimal that you can work with. You want to use a calculator to do that? Go back to the Google calculator. Should just use this one with you guys because you guys are used to seeing this one anyways. It's 5 per cent, which means 5 per 100. 5 divided by 100, 0.05. So that's how you can figure that out. And then that's the number we're going to use here. And so that's just the exponential function. We are going to also remember about PEMDAS order. PEMDAS. 1 minus 0.05. Let's do that first. So 1 minus 0.05 equals 0.95. 95 hundredths. That should make sense. That's true. .95. Okay. Now we're just going to rewrite 32,000. And we want to find the value in 3 years. So 3 years, that's our time interval. That's little t. I use pink. And so it doesn't say in 3 years up here, but it says you started in 2010 and you're ending up in 2013. So the difference between that is 3 years, and that's where this 3 years comes from. T equals 3. So I'm just going to plug in all these things, and then we're going to evaluate it. 32,000. .95 hundredths. So all they did is rewrite this because they're taking it from right here. That's why they're writing it so many times. When you guys actually work this stuff out, you don't have to write this much, okay? The reason there's so much writing right now is because we are learning how to do something new. So it helps to write out every single little step. Your exponent here, what's this going to be? What's my exponent going to be? What do you think? You could type it in the chat. What do you think my exponent will be? Nobody? You guys have no idea? What's t equal? We wrote it in pink. What is t equal? Yeah, 3. Kobe and Quaylon got it. It's 3. So this is what we're plugging into the calculator over here. Again, PEMDAS order. Don't forget about PEMDAS. You need to deal with parentheses first, like we did up here. But now I'm dealing with exponents next. Type in your base first if you are using the Google app calculator. Then press the X to the Y power button. Then type in your exponent. Then hit equals. Then multiply by 32,000. And have to round. Why does it say approximately equal to? I didn't round. Interesting. I'm not really quite sure why they have an approximately equal to symbol here. Where did we round? I don't remember rounding. Did I round when I took the third power of this? That's not exact. That's approximately equal to. I don't know why there's an approximately equal to sign here. So, and they're not saying approximately in their answer. They're saying after 3 years, the car's value will be. They don't say approximately. So this is a typo. Sometimes you find typos. I just found one. So what you're going to do is get the pencil tool and just color over the approximately to equal sign because that is wrong. And then you can get the line tool and you can make an equal sign that way. Okay, because it is exactly that amount of money, not approximately. Little details count in math. All right, so that is your exact answer. Okay, I am at time. So end your lesson and take a 5-minute break. Come back and do your HMH assignment.